all the exam questions that NCFE publish. So we've done all the mock exams, and they're all available on Atom. Quickly just get it up on my screen. They're all available in Atom. So all the exams that are still in, when I say circulation, they've been retired from people actually sitting them and getting grades. However, they're still in circulation and available to do. So if we went to live, after logging as me, actually, if I log in as me, then you can see where they are. So go to here, Steve demo, log in as me. So if you want to look at any of the exams that have been done in the last sort of few months, by exam and also by topic. So by topic, and when I say by topic, we're looking at clubbing all the questions together with one particular subject, or by exam, they're all here. Look, so you can see we've hit non-calculator regularly, so we've tried to do the 30-minute of non-calc questions in one sitting to show you the speed you've got to work, what I would write down in the box, and obviously the calculations that are needed to work out. And then we've got particular workshops on areas. We've got 4 pages worth, but it does tell you exactly what the workshop was on: angle, shapes, compounds. So if you're finding a topic that you're struggling with and it's not on my list here that I've already covered, then please just shout out to me and say, Steve, can we have a session where we go through that? This session today was at a request of somebody else. They can't make it today, but they were looking at watching the session back and completing that in their time. So what I do with these sessions, we're looking at questions just on percentages. As you can see here, there's no non-calculator sign. So if we saw that symbol down the side of the page, it means we can't use a calculator. Of course, we could work out these without a calculator as well. It just takes a little bit longer, but with a calculator, these sort of questions should be at level 2 quite straightforward, and at level 1 within your capabilities. So what we'll do, I'm going to get my pad. I'll just move that calculator a little bit so I can kind of, I'll put it on this one for now because it's below that, isn't it? I can't see. I can still see question 1. Right, so with question 1, with it being a calculator paper, find 11% of 250. If it didn't have a calc, that's a weird percentage, isn't it? I don't know why I did that. If it didn't have, if it wasn't non-calculator, we'd find what 10% was, which is 25, and we find out what 1% is, which will be 2.5. So in theory, we already know that that answer for that question is going to be 27.5. However, we're allowed to use a calculator. So the best way to do this is change this number to a decimal, which we do that by dividing it by 100. So that becomes 0.11, and then multiply it by the number you want, 250. And that gives us our answer. So if we did 250 times by 0.11, we've got 27.5. And if I was seeing that question on an exam paper, would I straight away do it in my head and say 27.5? Probably not, because if you're allowed to use a calculator, why not use a machine instead of your brain? But if I was to back it up in my head with that calculation that I did here, I know that I've pressed the right buttons on the calculator, or flip it around. I know that I've got the right method when I'm doing it non-calculator. And we can do the same with this one. We find out what 10% is, and we find out what 1% is. And then you can work out anything. If you find out what 10% is, which is 72, and then you find out what 1% is, which is 7.2, we can times the 1% by 4. So 7.2 times 4, 28.8. And then we can times the 72 by 9, and we've got the answer. But we're allowed to use a calculator, so we do exactly the same method. 94% of 720. Flip that into a decimal. So we go 720 times by 0.94. And that's the same for the first 1, 2, 3, 4 questions on there. So I won't do question 3 and 4. But what I will do when I send this out, if you guys are looking at these questions and thinking I've not got the hang of it yet, then absolutely do questions 3 and 4 and you'll get the swing of it. So if you look at what I'm doing, I'm changing the decimal, the percentage into a decimal by dividing it by 100 and then just multiplying that decimal by the number we've got. And if you notice, we said before that 4% will be 28.8. That's where our 0.8 comes from. Look, and then we'd have 9 times 72 for the other part. So we would be right again with non-calc. So I'm not going to do question 3 and 4. 3 and 4 on sheet. So have a go at those when you come around to doing this workshop. When we switch into questions 5, 6, 7, 8, we're now looking at what is 30 as a percentage of 200. So they're all asking the same thing. And when we see a question like that, so without writing it in full, it's hard to do it. 30 as a percentage of 200. So when I see a question like that, I'm looking at that straight away as a fraction, and it's saying to you, what is 30 over 200? That's exactly what it's saying. What is 30 as a percentage of 200? So it's saying, what does 30 parts represent as a chunk of 200? And how do we work that out? Well, for any fraction per decimal, we do top number divided by bottom number. And then from any decimal to a percentage, we literally get times by 100. So whatever we get here, we times that number by 100 to get our percentage. So what we're going to do here is do 30 divided by 30 divided by 200 times by 100. And we've got 15. What some people do is they do it slightly different. They do the 30 divided by 100 times by 200, but it's just switching the numbers. It's just switching the numbers back round, if you know what I mean. They're doing exactly the same sum. They're just switching where they would do which bit they would do times and which bit they would do divide. But it gives you exactly the same answer. For me, again, if you're comfortable doing it in a different method and you're getting the same answer, as in that you're getting 15, then absolutely carry on using your method. Maths is a subject where all over the world it's taught slightly differently and we get the same answer. For me, I've got used to doing certain methods. Some are done from way back when I did it in school 35 years ago, and others are ones I've learned more recently because somebody else in my sessions has suggested something to me, and I've seen it at a light bulb moment and thought, oh my God, that is so much more easier. Let me do it your way. And it's stuck with me. So yes, if you find ways that you're comfortable with, please stick with those ways. So again, same sort of principle, 96, and we'll just do 2 of these as well. 96 as a percentage of 1 to 8. So again, it's asking you, it's giving you the numbers, it's telling you what to do. It's saying, put it as a fraction. We want to know what 96 pieces of 128 is worth. And so we're going to go top number divided by bottom number times by 100. And that's going to give us our percentage. So let's do that. We got 96 divided by 128 times by 100 equals, and that's where we get to. Let's go 96 divided by 128. And the only thing with a calculator I would say is sometimes I do it twice just because I'm not sure I pressed the right button. So if you're kind of like under exam pressure and the answer looks weird. So say it was, I don't know, we got 752 there. I'm like, whoa, that can't be right. I must have pressed something wrong. So do the exact same calculation again, just to be sure you've put the right numbers in, because everybody makes mistakes. Sometimes I accidentally hit the not button instead of the point button. And it is, or sometimes I press divide instead of times. And it's, yeah, with a calculator, because it's instant, and quite often it doesn't show you what you're doing up here. A computer calculator obviously does. It shows you what kind of calculations you've made. But on a normal calculator, where's my normal calculator? On a normal calculator, it doesn't kind of show you where you've made the mistake. So if you think the answer looks a little bit wrong, the best thing to do is check it. So we're going to say 7 and 8 on sheet. So again, follow the method. It's showing you what the number is here. It's a fraction. As you can see, this one is a little bit different. Still do the same thing. It's asking you what 310 is as a percentage of 217. So it's going to be over 100% because it's a larger number, but don't worry about that. That's the fraction. The 310 is on top, the 217 is on the bottom, and then divide it into there and times it by 100. So then we move on to the next set of questions. We're looking at percentage increase and decrease. So for these questions, the best thing to do is understand the 100% number. Okay, so have we got the 100% number and we want a bigger number, or have we got a number that's already above 100% and we want to bring it down to 100%, or have we got a number that's less than 100% and we want to bring it up to 100%? So when you see sales and stuff online, or you're buying one, get one free, or you buy one, get two. So you buy two and get the third free, you're looking for percentage increase and decrease. Those sort of questions, when it comes to maths, when we're shopping, we don't. So, wow, that's 33% free. We just simply see it as buy two, get one free, or, buy one, get the second one half price. So we don't actually realize that's everyday maths all the time when we're in the supermarket. We're kind of figuring it out, what's the best deal. So let's have a look. Find the value of 655 after a 4% increase. So that's saying basically 655 add on 4%. That's all it's saying. If you've got percentage on your calculator, which most calculators do, some calculators don't. If you're bringing a really, really basic one into the exam, then it might not have that percentage button on it. But if it does, do what it says here. 655 add 4% equals. And that's the answer. That is as simple as it gets. When you've got a calculator and it's asking you those sort of questions and you're thinking, oh, I'm not very good at percentages, just follow what it's asking you to do. If you didn't have that percentage button on your calculator, that doesn't make it any more difficult. We're going to go 655 times by 1, because we want it itself, and 4%. So that's 4%. If we remember what we wrote above, when we find a percentage to a decimal, we divide it by 100. So 4% as a decimal is 0.4. If we times it by, let me just go on here. If we times it by 1.4, thinking, oh yeah, that's 4%. No, because if you think about it, the 0 doesn't show, but that's 40. That's 40%. So we don't want 40, we want 4 extra percent. So we want it, the whole of it, and 4% more. So we don't have a percentage button on our calculator, but what we are going to do is simply type in that number, 655, times by itself, which is 1, and we want the extra 4%. And we got the same answer. If you're thinking, I want to do it a different way, I find out what 4% would be, then I just add it on. That's absolutely fine. You can find out what 4% is, like we did above, where we literally did 655 and we would have times it by 0.04, which equals 26.2, and then we add it on to that. So you can do it the same way. And again, do it the way you feel most comfortable with. Let's get rid of that one. So that one is there. That's an increase again. So that's exactly the same. Again, think about that number there. When we're talking 30%, so we're going to times it by itself. So that'll be the 450, that's the one. And then it is 32.6%. So we just write that number like that. And that would give us our answer. So I'm not going to do that one. I want to look for a decrease one. So let's look for a decrease one. So we've got a decrease one here now. So we're going to go Q10 on sheet, Q11. Right, find the value of 371 after a 13% decrease. So 371 minus, because we're decreasing 13%. And guess what? On the calculator, if we've got that percentage button, that's as easy as it gets. 371 minus 13% equals. That is all you would do if you have a calculator that has percentage. Oh my gosh, that was a bit of a spooky 3. 322.77. With those sort of questions, I'm not saying go out and buy a calculator that has got percentage on there, because it's just as easy without the percentage button, but it's just following that process of, if I've got a percentage button, use it. If you haven't, then what we're going to do on this one, if you can see here, the relationship is minus 13%. So if we go 100 minus 13, sorry, I'm going to sneeze. My hay fever has just started today, so that means that all the trees are going to start budding and flowers and weeds are going to start growing. 100 minus 13 is 87. My goodness. So we want 87% of our original value, because we want to take 13 off. So 100 take away 13 is 87. So now it becomes like this one again. We're just going to go 371 times by 87%, so 0.87. And that's what we're going to get to when we got the same. So 371 times by 0.87. So think about it as being the amount you want left. So above it was a straight follow the calculator with what it's telling you to take away 13%. Without the percentage button on the calculator, think, right, if I take away 13%, so 13 parts of my 100, I'm going to be left with 87. So I want 87% of that number. To do that, I times it by the decimal equivalent, which is 0.87. Again, if we weren't sure on that method and we knew how to work out what 13% was, so if we went where we got 371 times by, oh, I know what 13% is, because that's just do 0.313. So that's my 13%. And then take that amount away from 371. We're still getting the same number. So again, 3 different processes. Use a calculator with the percentage button on, just follow the rules. Without a percentage button, take the amount you are taking off, 100, and times it by the amount that's left. Or find out what the percentage is and just subtract it from the actual amount. So that would give us 11 and 12, decrease. Find the original value. Okay, so this is where we're getting good again. So these sort of questions, always think about which is my 100% value. So 12 on sheet. So scroll down to question 13. Question 13. Right. Find out the original value of a shirt bought for £27, given that it was discounted by 25%. So shirt now £27 after, and again, I don't want to write the question down in full because it 20%. Shirt now 27 after 25% discount. So what is it saying about that 27? It's saying that that's the value after I've taken off 25%. So my 100% value, take away my 25% equals my 75%. So I know that that shirt is now representing, oh, I'm going to put I'm going to put percentage. So 75% is my value of my shirt. It's worth 75% of its original value. So the way I do this one is I'm going to divide my £27 shirt by how many pieces. I'm going to say 75 now because it's still 75 pieces. Divide it by 75. Then I'm going to multiply it by 100 because that's the value it is now. And I know that it's 75% of its original value. And then I'm just going to times it by 100. So what you do with that one is you're almost splitting it into the equal parts after you've taken that percentage off. So if we work it out like that, so 27 divided by 75. So we now know that equal part is 36p times by 100. And we can now see that that shirt was cost us £36 to start with. If you want to check your workings out for that one, simply you could times that by 0.75, get back to 27, or you could times it by 0.25 to work out what a quarter is and then take that off it. Or if you could do it in your head and thinking, oh, 25%, you know, that's worth 3/4 of my original amount. So I just add another quarter onto that. So I just add another £9 onto that, and I know what I'm doing. So when some of the numbers are quite straightforward, which if you're going to get them in a non-calc, I know this doesn't say non-calc on the side here, but you'd get these sort of questions where it's talking percentages that you're familiar with, 25%, 75%, 10%, maybe 20%. You'd get those on the non-calc. You wouldn't get that simpler percentage on a calculator paper because they're expecting to know the process. Okay, so let's have a look here what we've got here. And we'll do question 14 because it's asking us now the word problems. A gym price structure increases by 15% in the new year. David sets up a yearly membership costing £402.50p. How much did his yearly membership cost last year? So let's go. Increase is 15%. Now 402.50. That's the quickest way I can write that without writing all those words that my writing's not the greatest. So what did we do here? We looked at the discount of the shirt was 25%. So we worked out that the value of the shirt was now only 75% of its original worth. This is the opposite. We've got our membership was something, should we want to find out, and it's added on 15%. So we can see that this value is now, so 115% is now £402.50p. So that's saying your new value is your old price, added your new price, which is 15%, and that is now saying it's £402. So we do a very similar thing what we do up here. Instead of dividing by the small amounts we want, we divide it by the full amount. So we're going to divide 402, divide it by 115 because we want all the parts we've got right now, and times it by 100. So same process. Number of parts we've got 115 parts because we've got the 15% extra, and we only want 100 of them. So hence why we multiply it by 100. So £402.50 divided by 115. So that's what one part is worth right now. And then last year we want 100 parts. So we times that by 100. And we can see that the gym membership last year was £350. Okay, so is the next question similar word problems, or is it getting something more difficult? Let's have a look. I've only got one question left. Okay. In 2020, in the UK, the UK's CO2 emissions decreased to 326 million 0.1 tons from 365.2 million tons in 2008. What is the percentage change? So this is these two are really good questions because hold on, what? Okay, oh, that's the year after. I'm thinking, what? It's saying it's changed again. Okay, you are going to get questions, definitely. Not in every exam, but I'd say in 2 out of 3 exams. So how NCFE and Pearson work is they have a bank of questions. So they have a bank of 200 questions, some from each topic, and you have to have a certain number of topics appear in every exam. So you're going to have core topics. Percentage change is not a core topic, but percentage is a core topic. So you're going to have a question in every exam that talks about percentages. You might have a percentage increase or decrease like above, or you might get here like a percentage change question. And hence why, you want to cover all bases by understanding all of the methods for all of the questions we've done. So question 15, we'll do both of these so you can see it twice. When I see that word there, percentage change, I think of one word, and it's not the whole equation, but I think of that word, no. And the reason I think of no is because of the formula to work out any percentage change question. So N stands for new. Oh, it says nev. Let's get new written properly. That stands for new value. Take away old value. Okay, so that's my no, N and O, so N and O, so that's why I think of no. And then we divide that by old value. And again, oh my gosh, that's all right. N and O. So that's why I think of the word no. If I think of the word no, I know I'm going to get my numbers in the right order. And if you look at that now, I've created a fraction. I've got my new value, take away my old value, divided by my old value. That's my fraction. So when I get a fraction and do that with it, divide bottom number into the top number, I get what's called a decimal, which we did above. And we simply times it by 100 to get our percentage. So it's the same process, as in like top divided by bottom times by 100 to get our decimal into our percentage. However, we have to take away the values first. So if you have a question that asks you for percentage change, the word order, no, is the right formula. So we have N and O for no and N and O for no. So in that question, in 2020, they decreased to 326. So we got 326. This is the new value. It's decreased to that minus our old value, 365.2. And I notice I'm not putting it into millions, which I could, divided by our old value times by 100. And the reason I'm not changing these numbers into the millions is because my calculator skills, my fat fingers aren't great, but it makes no difference because we'll be only making both those numbers into millions and that one into millions. So it become out exactly the same answer. So do as what it shows you on how it shows you on there, unless it tells you, but it doesn't tell us. So let's go those numbers exactly. 326.1 new value, what it's come down to, minus our old value, what it was last year. And again, that's just creating you a story, equals that. So that's the top number. It doesn't matter, it's a minus. Divided by 365.2. And again, looking like, whoa, my God, what is that number? Don't worry, we times it by 100. Times it by 100. Aha, now we've got a number that we can recognize that's not like crazy long. Equals minus 10 point, we'll go to 0.71, we'll say to 2 decimal places. So the second decimal place is decided by the third number. If it's 5 or above, then that number goes up. If that's 4, 3, 2, or a 1, then that stays at 0. So we're going to move up to 7.1 for the sake of this 2 decimal places. We'll go 2dp so we know what we've done. And we're saying it's minus 10.71 percentage decrease. What is the percentage change? It's minus 10.71. If you wrote for your answer 10.71%, you're getting a point. You're getting the same amount of marks because it's not, the minus bit's irrelevant. It's asking what the percentage change is. It's changed by 10%. If you put the minus in there, it's still going to give you the exact same point. That's not too important is the minus part in this. It's asking you for the percentage change. It's changed by 10%. It's already talking about a decrease here. And let's look at the next one. In 2010, the same statistic was 495.8 million tons. What is percentage change between two? So it's the same, exactly the same. We've got old value, which is 49. Right, well, 49. What have we got here? My goodness, we've got. It's not the old value, is it? It's the new value. This is still the new value because we're talking historical figures now. 495.8 divided by 495.8 times 100. So we're talking, it's trying to kind of give you some really big numbers there to work with, but again, don't worry about what comes up on a calculator. When I see that number, I'm thinking, oh my God, what is that talking about? But wait till you've times it by 100. And if it still looks really odd or off and you've thought that doesn't look right, do it again. Have a go at it again. Have a type the number in incorrectly. Have a press times instead of subtract. Just do it again. If it doesn't look right, I'm forgetting where I'm divided by 495.8 equals that times by 100. So in the 10 years since the CO2 emissions thing started, we've decreased by 32.23. Same again, 2dp, and or 34.23%. And those sort of questions are really quite common. The percentage decrease and increase, it's sometimes saying a football stadium's got this many people in this year or last year. What's the increase between crowds, or a concert ticket sold this many tickets this year? Next year they're hoping to sell an extra percentage. So that would be one of these sort of questions, or it'll say this was the figure they sold this year, that was the figure they sold last year. What's the difference? So that's the no. If it's giving you two numbers and asking you to work out the percentage change, the difference between those two numbers, it's this. It's no. NO. New, take away old, divided by old, times 100. And I know by just saying no, it doesn't automatically make you remember it, but at least it gets you in the right order. You have to still N take away O and divide by O, but NO gets you in the right order. And that's all the questions we have on let me just save. Let me save that. Let me save that so I can send it out as a blank. Percentages. There we go. Save that one, and then let's rewind that. What we'll do next time, we'll have a go at it says choose resource. Worksheet questions. We'll have a go at the ones where it's mixing everything up. I mean, you're not going to get a question like that on level 2. Definitely not. It's definitely pitched at people that are working at level 1. So you're looking at matching the fractions up. Sometimes it has the box where you drag them and put them in there. Convert it into a decimal straight away. We're just getting rid of the percentage and putting a point in front of it. Same here. These are non-calculator though, so think about these ones as a non-calculator. If we were to look at some of these as non-calc, and we're looking at all of those, oh wow, they're all good. Okay, so this is quite good. These are all non-calc. Let's go. Okay, let's have a look at a couple of these. So we're on what is this one? This is the fractions, decimals, percentages worksheet. Okay, that table for me, we're talking a half, we're talking 25%, we're talking fifth is always a tricky one. People always get a fifth, and sometimes they put 0.5. Obviously, that's a half, so don't be fooled by a fifth. Once we've got the decimal, it's just 20%. Tenth, 0.1. What is 5% if we're looking at 5% as a fraction, if you think about it, it's 5 over 100. That's what it's saying. But can we make it smaller? Absolutely, yes, we can. We can make it into 1/20th. So you're putting 1/20th in there, and then that would be 0.01, and then 100% again as a fraction. I'd be tempted to say it's 1 over 1, but if you wrote 1 you're going to be all right. And if you're at 100 over 100, you're still going to be all right. But for this table, it looks odd and looks weird, but I'll be putting 1 over 1 just to suit with the rest of them as a fraction. That isn't actually a fraction, it's a whole number, but it is the right answer, you know, as a fraction. 1 is. Right, okay, so have a look. Convert this to a decimal, straightforward. 45 is 0.45. We've just taken off the percentage signs. Same here. If we got 0.06 to a percentage, times it by 100. Without a calculator, we're moving at decimal place. So when we times by 100, decimal place, 2 decimal places to the right. When we're dividing by 100, 2 decimal places. Oh my gosh, I'm getting all my letters and words. I'm getting all my letters and words mixed up there. Let's tidy that up. When we're dividing by 100, 2 decimal places to the left. 10 will be 1 decimal place to the right, 1 place to the left. 1,000, 3 decimal places to the right. So however many zeros you've got here, yeah, that's how many decimal places you're moving it. So when we're moving a decimal into a percentage, we're just going to literally times that number by 100. So we're going to go 1, 2. As you can see, 6%. Okay, and it's a giveaway. Obviously, if we're saying it's 0.6 and we've just filled in this table here, we know that 0.6 is more than 0.5 and 0.6 was 50%, so it's not going to be 6%. So recognize your numbers here. 0.05 is 5%, so 0.06 is 6%. If you knew that straight away, they're the sort of questions that you're going to gobble up those 1-pointers on the exam. And there won't be many 1-pointers. There'll be a few scattered around, but there won't be many, so make sure they count. As a fraction, 7 over 10. If you wanted to say, oh, actually, it's 70 over, oh my God, 700. It's 70 over 100. Yes, it is, but don't forget, we can make those both go small, so it's 7 over 10. Looking at that, convert that to a decimal. It's just trying to tease you there. 0.91 is our decimal because it's saying that's 91%. So it's not trying to kind of give you a real tough question there. As a, what have we got here? As a percentage, that one, if we look at this one, I'm going to put it on here, question 6. Suddenly, our calculator has been lifted. Should it be lifted? If we look at this one here, and I'm thinking, oh, wow, that's not 100 anymore. That's a really weird one. Well, we go back to the method we did on the first worksheet. Top number divided by bottom number times by 100 to get our percentage. But if we look at that number here, I can see that that divides by 11. Okay, so that's 2. And that also divides by 11. And then now that divides by 2 and that divides by 2. So I can see that actually 22 over 110 is the same as saying 1/5. So I don't need my top number divided by my bottom number times by 100. I know that 1/5 is 20%. Not only did I fill it in on the table up there, but I just know that 1/5, if I split 100 into 5 equal pieces, I get 20 for each piece. So when it comes to some of these questions like that, and it's offering you a calculator, use your calculator. But if you see it straight away, hang on a minute, that looks familiar. You know, I can shrink that into 1/5. Then don't worry about calculator. We're looking at some of these. That's the same. Now we've not a calculator, but 59 over 100. Can we shrink it? Which is greater than? So it's asking you here, which is greater than. No calculators. We look at that one. We've got 92%. Or we've got 96. Oh, I'm going to say 96%. We've got those two numbers. We know that that one is a decimal. We move it that way. So we've got 0.92 or 0.96, which is greater 0.96 What is greater, 5/4 or 123 or 1.23? Same principle. If we've got 4/4, that's a full one. We've got 1. And if we've got another one, what is 1/4? 2/5. We can clearly see that 1.25 or 5/4 is bigger than 1.23. And we look at the next one, same again, it's a non-calculator paper, but 25 is a good number to use because it's a direct relationship to 100. So when I look at those numbers, I know it's going to be close, but in my head, I know that 12.5 is 50% of 25. I just divided it by 2. And I know 0.5 is 50%. So 13 is bigger than 12.5. So 13/25 is bigger than 0.5. If I wasn't sure, if I times that by 4 and times that by 4, okay, I get 100 there. And then I get here 52. Oh, right, yeah, that's 0.52. So yeah, 0.52 is definitely bigger than 0.5, but recognizing it as a fraction and thinking, oh, well, that's a half. That's more than half. Sometimes your workings out are done in your head and they're really straightforward math rather than having to do it, the actual calculation. Same. Once you can start using a calculator, my absolute advice is as soon as you can use a calculator with comparison fraction decimals, you get questions that will say, right, let's go, no, let's not go 1/3, let's go 13/18. And I don't know the answer to any of these, by the way. We've got 67%. We've got 0.69, and then we've got 3/8. Okay, I made those numbers up on the spot. We might say compare which is the highest. Straight away, all decimals. Okay. I spelled decimals wrong today. So we've already got one decimal, 0.69. That's fine. We can see a percentage. Okay, so straight away as a decimal, we know that one. The other two, no idea. Let's do it. We've got a calculator. We're allowed. Top number, remember, top number divided by bottom number gives us our decimal. Oh, typical, crazy numbers. We'll say, that's what I told you, I made the numbers up on the spot, so you can tell why. And then 3/8, 3 divided by 8 equals 3.75. Okay, 0.375. Right, so we've done all those numbers in a flash on a calculator, and we can clearly see now if we said largest to smallest, largest is that one, second largest is that one, third largest is that one, and fourth largest. The question would expect you to put them back in that order, so it'd say 13/18 followed by 0.69, followed by 67%, followed by 3/8. So it expects you to put them back in the format how you found them. We've done the math and put them all in decimals. Brilliant. To actually verify which one is smallest, which was smallest, but put them back in the order that you actually see them in the question, and you're not going to go far wrong. Okay, so we've had a quick look at most of those questions, and I don't see anything that's going to trouble if you know the fraction decimal percentage changes. If we go to have I logged in as me? No, I didn't. I thought I logged in as me. If we go to my learning and click on, oh no, I was showing in the exams. Go to my learning. It's going to come up. And you go to number. There's some good challenging questions. And I say challenging, if we've done these worksheets that we've just done in today's session, these ones are not as many questions of the same type, but the questions get harder quicker. So we've got a whole set of questions with fractions, a whole set of questions with decimals, a whole set of questions with percentages, and then mixing them all up. So you've almost got 4 mini sections there on fractions, percentages, and decimals. And what people don't realize is that they're exactly the same topic. We're just showing the number differently. So fraction is a decimal. is a percentage. It's just how we write it. So if you've cracked a fractions lesson, you should find the decimal lesson again straightforward. If you've cracked both of those, should definitely find percentages. So once you've cracked the whole fraction, decimal, percentage, oh, I don't like fractions, but I like percentages. Hang on a minute. It's the same number, it's just expressed a little bit differently. So please, 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 understand that if you're scared of fractions, but you're not scared of decimals or percentages, then think of it again and think of it as being a fraction is a decimal in disguise. A fraction is a percentage in disguise. It's just showing you it a different way, and then you'll be able to tackle the questions again. Obviously, we all get questions wrong. My biggest fault is reading too quickly of a question, so I've missed a word out, and it's changed the whole outlook of the question. So, yeah, I don't expect anybody in an exam to get 100%. The pass mark for both level 1 and level 2 is 36 marks out of 60. And if you think about that on a percentage scale, 30 is 50%. So it's asking you to get a little bit over 50%. It's asking you to get 55%. If you get 36, 37, brilliant. If you get 35, okay, you've just missed out, but that's a real good kind of signal that you're on the right track. If people are getting 45s and 50s, amazing, I'm doing something right. Or actually, you've got a good math brain to start with. So, right, let me stop sharing. Let me stop recording first. And so we can get that one